All right. So.
Tell me when you're doing something. Also, the added above showing law is like the most terrifying place.
I'll tell you. So we have some, the med class. We have some fun people to present. But my favorite that presents, every time. I always love, and Rachel can attest to this, the Navy SEAL.
Oh my God, that guy was awesome.
Guys, if you think I am good with stories, you think I have stories? Navy SEALs, man, they have some stories. It's awesome. So
what did that one guy bring for the show until it was a heart?
Oh, the perfusionist? Heck yeah.
It's just like a bunch of stories. Like that's kind of what it sounds like. Is just like a bunch of stories.
You get the ins and outs of what that person might have done for their medical experience. Okay, so a reminder, lots of you are doing this, so my stack is getting more thin. So Blake and Ben and Drew and Clay and Ashwin and Cooper and Logan and Grant and Eduardo and Riley and Peyton and Kate and Miwa and Lieb and chilling with you. Teach them Algebra 1. And Hannah and Olivia and Parker and Landon and Fiona and Ava and Kyle and Michael is not here and Grant, here's the second one. That's the graphing sine cosine tangent. Cooper, another one. Blake, another one. Cooper and Blake. Well, 2 because one's 2 different pages. One calculator, one. That's on the logs.
I have a question for you. I'll get the cold thing, like the Schoology thing. I took it. In the last question, I did 12 different answers. I'm like, I have no clue what it is. And I literally could not get it right. Do I still have a chance to take it?
Is it the very last one?
What? Yes.
Let's pull it up. We'll do it. We'll do it so you can all right. Yeah.
I got this. It's not too much, bro. And I had no idea how difficult paracord is. It's been literally 3 seconds since I was again.
All right. Cool. Let's do it. All right. So, I've had a couple questions on the very last one on Desmos, and this goes along with the capstone review for logs, and this problem is very similar to what you would see on the capstone. It says you buy a Tesla for $138,000. Okay, I just pretend I have it at the right price. I don't know. It depreciates at 7% per year. So that means each year you have it, it's worth 93% of what its previous year was. That makes sense so far. So the equation's given to you. How many years until the car will be worth $40,000? And it says use the Desmos graphing calculator on it. Okay. So we're going to hit the Desmos graphing calculator. And so you get y equals 138,000, and then this is 0.93, and then that's raise the x, I think that's right. How do you do it? And then we want it to be worth 40,000, so I'm going to make a second equation at 40,000. Oh, that's in a section. Okay, so can I see 40,000 right now on my graph? No. So I have to probably zoom out a whole bunch. I can now start seeing the one graph, but I still can't see the other one because I'm only at 200. So scroll out until you get to the 40,000. Now, can you see both of them?
Yeah.
So it might show it now, or I might have to zoom in on it. And this is what you would do on the computer. You'd have to sit there and zoom in until you feel you can see it, and then you hover over and you push. And it looks like in 17.064 years after you bought this Tesla, it's now only worth 40,000 versus the 138. Okay, and that's exactly how you do that problem. Does that make sense?
Yeah.
Everyone get that? Yeah. So if you're struggling with that one, that's exactly how you should walk through that problem.
So like on one of the questions it says like 5 to the power of 2x minus something equals 11.
One of these?
Yeah.
Which one do you think?
That one.
This one?
Yeah.
So if you're going to solve using Desmos on this,
Yeah.
I'm going to go Desmos calculator y, or I'm going to change this. So that's going to be y equals, I just forgot. 5 raised to 2x minus 7. 5 raised to the 2x minus 7.
Yeah, I do.
Oops. I have to put that in parentheses.
Oh, okay.
2x minus 7. There we go. And then the other side was 11. Done the exact same way. Okay, so I can't see it now, but
Yeah, I just had a problem with the picture.
now we should be able to start seeing I can kind of see both right now. So it's at 100, maybe take down to smaller. So now I can definitely see the intersection. So 4.245 is your answer, or 4.245. Cool.
How do you do natural lines on there? Because I'm trying to type it in and it doesn't work.
ln
Oh, okay.
y equals ln.
Okay.
So recognize it. If it ever doesn't show up, done. There's a drop down.
Oh.
There's there, and then go to functions if you want to go to functions. Should be an ln someplace.
It's right there.
There it is. So you can also do that, but it'll recognize ln as ln as well.
Okay, cool. And then for log, you just type in
log.
Sounds good.
Yep. Yeah, it defaults to that. Cool. All right. Life good?
Yeah.
All right. Let's talk about homework. It was what letter? M. And I have homework coming around. Is that right? Yeah. Okay. Let's take a look at homework Emma. What kind of questions did you come across on M?
You number 9. Number 9.
Number 9? Okay. Number 9 on M. 5 log base 3 of 3 plus log base 3 of x. Oh, wait. I goofed up.
No, yeah, what?
That's right. Cool. Equals 3. All right. We want to condense it first. We do have some exponents. So I'm going to make sure I move this up here. So 3 to the 5th. 3 to the 5th is, I think, 243. So this is going to be 3 to the 5th. Is 3 to the 5th 243?
Yes.
Okay. 243. And then I can bring the x over because it's added. Equals 3. All right. So what log base am I to right now?
3.
3. So I'm going to go 3 raised to the and 3 raised to the. So that cancels those out. So I get 243x equals 3 to the 3rd, which I think is 27. And then divide both sides by 243. So let's see. 3 goes into that 9 times. 3 goes into that 81 times. 9 goes into each. So I get 1 over 9 for an answer. What else would you like to see from the homework?
20.
20? You got it. Okay, and then, double check that answer. If I plug 1/9 in for that x, does this log become negative? Log negative? The answer is no, so that is the answer. Number 20, it's saying definitely check for extraneous, so we might come across an extraneous solution on this one. Is that right? Okay, so let's bring the logs over to the same side and we'll move the -1 to the other side. Is that okay? So I'm going to go log base 5 of x plus 3 plus log base 5 of x minus 1. And then I'm going to move that over by adding it. So I just manipulated the problem. So I have the logs on the same side. Is that okay? I can condense the left side, which becomes log base 5 of x plus 3, x minus 1 equals 1. What's my log base right now? 5. So each side is going to become its own exponent with a base of 5. So those cancel each other out. Let's FOIL this. So that gives me x squared plus 3x plus 2x minus 3 equals 1. Did I do, or equals 5, excuse me. That's a 5. Does that make sense so far? Did I FOIL it right? How do I solve the rest of this? What should I do? Yeah, make it equal to 0. Good. Thank you. So I'm going to subtract 5, right? So -8. If I factor that, I get x plus 4 and x minus 2. Is that right? So my answers are x equals 4, or -4, excuse me, and x is equal to 2. If I take either -4 or 2 and I plug them into the original logs. So on the first one, if I plug -4 and I get -4 plus 3, which is -1, what's log of base anything of negative? Undefined. So because this makes this become negative, it also makes this stay negative. That can't work. If I plug 2 and I get 5 here, I get 1 there. That's my answer. Okay, remember I can't have a log or a natural log of a negative number. Anything else you want to take a look at?
Number 10.
10? All right, let's take care of the exponents first. So we're going to move up everything up. Nothing to move up there, and that moves up as well. Okay, so that gives me log base 4 of x to the 3rd plus log base 4 of 6 minus log base 4 of x squared. And that's equal to 2. Is that okay so far? I can now condense it. So remember, if it's positive preceding it, it stays as a numerator. If it's negative preceding it, it becomes a denominator when I put it back together. So I get log base 4 of x to the 3rd, I guess 6x to the 3rd, over x squared equals 2. Tug of war. So I get 6x equals 2. Is that okay so far? So what's my log base on this one? 4. So my each side is going to have a base of a 4, and each side is going to become an exponent. So those cancel. So I get 6x equals 4 squared, which is 16. So x is equal to 16 over 6. And 16 over 6 is the same thing as 8 over 3. Double check. If I plug 8 over 3 into the original, I don't get a negative. I don't get a negative log. I might get a negative log of something, but I don't get log of a negative. So my answer is this. 8 over 3. We good? Pass it forward. Make sure your name's on it. If you're handing anything else up, please pass that forward as well. I have coffee someplace. I hope you guys are having a great day so far. Seems good. Well, I was driving to school this morning, and I left 10 minutes later than normal, so traffic always gets goofier. Boy, I came across this guy. He was a road rage and village idiot. I was just like, ooh. I was like, I was watching this guy. I was like, man, someone's gonna call this guy out and pull over to the side of the road and whoop on him. I wasn't the guy.
Should have been, man.
Last thing I need to do is show him I have broken glasses.
Maybe.
Yeah.
It's actually a year from today.
Birthday's on June 9th.
Yeah, I wasn't. This guy wasn't worth my time, but I tell you, I was just glad he got away from me because man, he was a big jerk. Oh, overcounting these days, huh? Any more homework that I missed?
Sweet.
All right. Let's head on back. All right. So this is kind of summing up a lot of things we do. So remember, if we are solving these, see if you can get both sides where you get the same bases. So, you know, if you had like 81, maybe change 81 to 3 to the 4th power. If you had like 16, maybe change it to either 4 squared or 2 to the 4th. Take the log of both sides. Unless you have an e in there, then take the natural log of both sides. This is just reiterating what I just said. If you have the same bases, if you have log base b of x and it's equal to log base b of something else, and there's nothing else with the equation, it's just log and log on both sides. It's the same base. You can set what the log is equal to each other. Make sure you move the exponents up top. Use both sides as equations. All right, so let's practice that. So 25, and I have two bases. I have a 25 and I have a 5. Can I make 25 in base 5?
Yeah.
Yeah, that's 5 squared, right? Mm-hmm. So the left side is going to become 5, 4x plus 6, and then 5x minus 3. Does everyone see where the 4x plus 6 came from?
Yeah.
Okay. Same bases now, right? So I can just set the exponents equal to each other and solve. Subtract x, so I get 3x. Subtract 6, so I get a negative 9. So x equals negative 3. I can have negatives as exponents. That's fine. That just flips over, makes it a fraction. So x is equal to 3 on that one. On number 2, can I make them the same base? Can I make 16 base 8? I can't. I can both make them both base 2. So I can make 8 2 to the 3rd power. So this is going to become 2 to the 6x. And that's going to be 2 to the 4th. So that's going to be 4x minus 4. Does everyone feel comfortable with what I just did? Mm-hmm. Anyone stuck? Okay. Set them equal to each other and dance it. Subtract, so I get 2x equals negative 4. X equals negative 2. We don't have any logs, but so we don't have to worry about extraneous solutions on this one. Seem good? May I move on? All right. Change your blue. Okay. So now we don't necessarily have log on both sides or same bases on both sides. So we need to start solving this. So my first move, I think most people would feel comfortable with that as my first move. Agree? I don't have e on either side, so I'm not going to use natural log. So I'm going to go ahead and do the log of both sides. And the log brings the exponents down front if you have those. Okay. Hey, what's log of 10? It's what? 1. Right? Yeah. Log base 10 of 10 is 1. Log base 2 of 2 is 1. Log base 3 of 3 is 1. Okay, so I just get 2x on this side is equal to log 152. Divide each side by 2. So you get log 152. And the whole thing's divided by 2. And then I'm going to go Go snag a calculator because you don't need to see me pushing buttons on the calculator. At least I hope I like that though. I don't know, makes you feel warm and fuzzy inside, right? So go log 152 divided by 2. So that gives me an answer of to 3 places. Cool. Next problem, I can subtract 1 from both sides. Can I put them both in the same base? Can I change 4 to base 2? Yeah, it's 2 squared, right? So I get x is equal to 2. Done. Okay, you'd get the same answer if you did the log of both sides. Not too bad, is it? Okay, moving on. Multiply both sides by 2. I have an e now, so what undoes e? ln. And realize on your calculator, ln and e are the same key, so that's kind of nice. So you get a little cheat code. So I get negative 2x equals ln 12. So x is equal to ln 12 divided by negative 2. So natural log 12 divided by negative 2. So it looks like I get x equals negative 1.242 to 3 places. 6, subtract 8 from both sides. I need to ln both sides. So I get negative x equals ln 5. So x equals the negative of ln 5. And you can indeed do the negative of ln 5. You just can't have ln of a negative number. And so that's going to give me an answer of negative 1.609. You doing all right?
Yep.
All right. Both sides are the same base. So I can just say 5x minus 1. Because it's just logs on both sides, I don't have to do much more. So I get 4x equals 8. X is equal to 2. Being you're dealing with a log, make sure if you plug 2 back in, that becomes 9. That works. That becomes 9. It works. Okay, remember I can't have, if I plug it back in and that becomes a negative, I can't do the log or natural log of a negative. This one, same way. They're both sides. You only have an ln. Let's see. Let's subtract 2x. Let's add 6. So I can find that x is equal to 3. Double check, make sure I don't get a natural log of a negative. So that's 6. That's 9. Natural log 9. Love it. Perfect. And 15. That's 9 as well. Cool. That works. No extraneous solutions there. Am I going too quick? No coughing. We don't accept that. All right. Hey, what's the base of number 5? Log base. So what's the exponent? Or what's the base now? It's going to be 5 raised to the and 5 raised to the right. Those cancel, so I get 3x plus 1. 5 to the second is 25. Subtract 1. Divide by 3. When you take your answer, plug it back in, I get 24 plus 1, that's 25. That works. Love it. Okay. Number 10, I'll wait till you're done writing because you have to see this on number 10 because this is a really easy error to make. I'm doing the log of 3x. Agreed? Mm-hmm. So if I move my exponent up, what is raised to the 4th power? 3x or 3x? 3x. So technically this should still be in parentheses. Okay? And I'll write that just so you can see this. Is that okay so far?
Yeah.
3 as a quantity, 3x as a quantity to the 4th power is a lot different than 3x to the 4th. Agreed? Okay, so I'm going to do, I have a base 3 on both sides, so 3 raised to the and 3 raised to the. Oh my gosh, 3 to the 20th power is an enormous number. I'm going to leave it as 3 to the 20th. Those cancel, so I get 3 times 3 times 3 times 3, that's 9 times 9, 81. X to the 4th equals 3 to the 20th power. This would definitely require a calculator because I don't think you want to multiply 3 times itself 20 times. Okay, so I'm getting a large number here. Okay, the number I actually get is like this. 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. Dude, that's big. What do I do to start getting x by itself?
Divide by 81.
Divide by 81. Cool. So it gets a little bit smaller. 4, 3, 0, 4, 6, 2, 1. I'm going to do the 4th root of both sides. Awesome. So I'm going to do the 4th root, and I'm going to do the 4th root. Now, so who's paying attention? If I take the square root of both sides, or I take the 4th root of both sides, or I take the 6th root, 8th root, or the even root of both sides, what does our answer have to have? Positive and? Both positive and negative. Remember that? That's very possible. The negative component is going to be an extraneous solution. So, oops, wrong thing. 4, 3, 0, 4, 6, 7, 2, 1. Raised to 125. The 4th root of that big old number is actually positive or negative 81. Which number can I discount? Will the positive keep it a positive log? Yeah. Will the negative keep it a positive log? If I plug a negative 81 in right there, this is going to become a negative number, right?
Yeah.
So I can't have a negative, so my answer has to just be positive 81. That's one of the big gotchas in math. Remember, if you take the even root of both sides, if you just took like the square root of something, if you just said, hey, what's the square root of 16? It's just 4. But if you had x squared equals 16 and took the square root of both sides, you'd actually get an answer of x equals plus or minus 4. So just be aware of that. That does take place. And that's an easy math operation to forget. Nice thing is, if you regret it on this one, it still worked out for you. We good? All right. So I don't have the first page. So let's write down what we know. So at the top of your page, it says the f-stops on a 35mm camera. Control the amount of light that enters the camera. Okay? So back in the olden days, your phones right now will adjust to automatically, the f-stops. On old 35mm cameras, if you're in a really bright sunny day, you need to click your f-stop to a different thing. If it's really dark, you click your f-stop, and that basically makes your opening go from really small to really large. Really large allows more light in. Really small allows less light in. That's what we're dealing with. Now, your cameras on your phones will automatically adjust to it. Have you ever tried to take a picture, like if it's dark and you can't see it right away, and then it becomes clear? You know what I'm talking about? Mm-hmm. That your camera right there is automatically saying, I'm adjusting so I can take as much light in as possible. If it can't let enough light in, that's where your flashes automatically for you. Okay? Does that make sense? So that's kind of the math that's taking place with it. They tell us this allows S to be the measure of the amount of light that strikes the film in your camera. It's your digital card. To be the f-stop. So they say then S and F are related by the equation that's given. S equals log base 2 of F to the second power. Okay? Some people call this, any photographers in here? Anyone ever take photography with Mr. Adams?
I did for like 2 days.
Did he ever say anything about the inverse square rule? Okay. This is where the inverse square rule takes place. Yeah? Inverse square rule, you ever hear that in photography?
No, I
The inverse square rule is basically one of the things you use. It has to do with the amount of light you're allowing in. Okay, so they want us to expand the equation where we don't have exponents. So that's going to be s equals 2 log base 2 of f. Okay, and I'm actually going to change this letter on your other paper. Change that to an s. Okay, I don't know why it came out as an a. I apologize. So they gave us some values. We can plug them in. And so if I go 2, and I'm going to use my log base on here, which was under math. And it's math under A, log base 2, and then I have 1.414. So this comes out to 0.999. Okay. If we were to round this, it would actually come out to 1.00. Okay. So we use that. And then I'm going to just change each of my values in there. And this becomes 2. And then 2.828. This becomes rounded up to 3. If you do it on a calculator, it becomes 2.99999956. Rounds close to 3. And then if I plug the 4 in, that's 4. Anyone want to complete the pattern? 5, 6, 7, 8. Okay, what's the pattern? So that's just how much light is being left in. We're letting 1.414 units of light in. Okay, so that's probably the opening of the aperture. All right, so then how many millimeter cameras have 9 f-stops? If you knew old school cameras, they more than likely don't have to a 9th f-stop. But if we called this, what do you think the 9th f-stop would be? That's 9 here. Okay, so that's my s value. So I'm going to get 9 equals 2 log base 2 of f. So I'm going to get 9 over 2, so that's 4.5 and divide by 2. Log base 2 of f. So how would I solve for f? How do I get rid of it? How do I get f by itself? What base am I right now? 2. So 2 raised to the and 2 raised to the. So 2 raised to the 4.5. This is going to give me, at the 9th region, it's going to give me 22.627. So 22.627. Cool? Yeah, we're doing all right. Okay, so that was a little interdisciplinary camera stuff for you. The nice thing is now our cameras, even if you went and bought a regular 35 millimeter camera, we don't use film any longer for the most part. We have memory cards we're plugging in. You guys all seen Action Jack, right? You guys know Jack's Action Shots. You know what I'm talking about? Yeah. So he has those cameras he's using are a different camera than what's on your phone. He actually has to do some adjustments, change lenses, things like that. There's times he has those big, huge lenses so he can take something really far away. Sometimes he has a close-up lens that he'll use. Why are his shots so good? Because one, on his memory stick, I was talking to him at one of our basketball games, and I said, how many photographs can you take right now on your camera with that memory card? And he said 10,000. Okay, and as soon as he hits 10,000, he takes out that little memory stick and puts a different one in. Okay, and gets 10,000 more. Back in the olden days, I remember my first camera. It was this little rectangular piece of junk. You could take 12 pictures and then you'd have to change the film. And then the 35 millimeters allowed you to get up to 24 pictures. And then if you really wanted to go hardcore, you could get up to 36. And there was a way to take the 36 and you hold in your wind key and the bottom button on it, and you can actually get the 37th shot on your film.
That's a loophole.
Yeah, a little loophole, man. We were cheating the system there. I need to develop my film. They're charging you for a 36 exposure. You got 37 pictures out of it. Man, thought we were living on top of the world knowing that little trick. Okay? All right, let's see. This last one. The energy in kilocalories per gram molecule required to transport a substance from the outside of a living cell is given by that equation. So now we got our medicine coming in. Okay? This stuff all takes place. It happens all the time. And it says C2 is the concentration of the substance inside the cell, and C1 is the concentration outside the cell. Okay? So I want you to think about this a little bit. If you have more pressure inside of a cell versus outside of a cell, it's easy for that cell to allow whatever's inside of it to come out, because it's going from a high pressure situation to low pressure. If you have a cell that's in a higher pressure situation and that cell has lower pressure, whatever is outside the cell feeds in. Okay? So condense the equation. All right, so if I condense this right here is the only part that's really condensing, and I would have an exponent. So I could do log of C2 over C1. It's both of those, and those will be raised to the 1.4 power. Okay? Now it says the concentration of a particular substance inside a cell is twice the concentration outside the cell. Okay? How much energy is needed? So if outside the cell, the concentration, let's say, C2 is inside, right? C2 is inside. So the concentration inside a cell is twice. So I'm going to make this. To the 1.4, that's a 1.4. So then your calculator, do I need to do 2 over 1 on my calculator? No. I can do log 2. Log base 2. Oops, I forgot my base. Base 2, base 2. Log 2. So the answer to this one would become 1 if you plug it in. This one you can do change of, oh, I screwed up. I messed up. I'm sorry. You can't trust me. Can't take me anywhere these days. Oops, wrong one. So I'm going to do log 2 and clear. Log 2 raised to the 1.4 divided by log 2. So the amount of energy wasn't 1, it was actually 0.619 kilocalories is what that. Does anyone know what a kilocalorie is? Kilocalories in medicine, rather than using small c for calories, you use a capital C, that means kilocalories. And is that done? That's done? Are you kidding me? I got done? So you guys know what the homework is, 9N, right? Oh. Woo! Got done. Nick time. Get out of here, guys, girls. Have a great day. Take care of one another.